All right, so we have this page about isotopes today. An isotope is an element that has a different number of neutrons. So it's the same thing. Like you could have an atom of gold and then another atom of gold, but their neutrons are going to be different. As long as the protons are the same, then it stays the same element. So those protons are the important part. They have a picture over here of the isotopes of hydrogen. So they gave, like each one of these has one blue dot. So that one proton is the same in each atom. But then this first one just has a proton with no neutrons. So that's protium. The next picture has one proton and one neutron. So they called that one deuterium. And then the third one here has one proton but two neutrons, so that's tritium. But they're all hydrogen. So each one is special. They have their own unique properties, but they're still each hydrogen. So an isotope, the neutrons in any atom give it what? What is made up from the protons and neutrons in every atom? So like everything in the nucleus makes up the mass. So these isotopes have a different mass from each other, which causes the difference in mass causes different properties or different physical properties. They might be a little different. Maybe it's a different color or have a different shape or something like that. And then these isotopes also cause different physical properties and stability. So some isotopes of hydrogen might be stable, and then other ones might be unstable. And that causes like radioactivity. Unstable atoms could be radioactive. So that's the gist of isotopes. Any questions about that part? So you can determine what isotope you're working with based on that mass number. The mass is the total number of protons and neutrons in the nucleus. Your atomic number is just the protons. So if you do the mass minus the atomic number, that's going to get you the number of neutrons, which helps you know if you have an isotope or not. So after you do this, your isotope is named based on those. Isotope named with the number of your neutrons. Oops. So like up there when they were talking about protium, that only had a proton. Tritium had 3 pieces. So actually they use both protons and neutrons. So if we're looking at this first example, tritium is hydrogen with a mass of 3. So they did this one for you. The mass was 3 minus hydrogen is the first thing on our list. Does everybody still have your periodic tables? We're gonna need those. So hydrogen 3 will be the mass minus our atomic number is 1. So that tells us that there are 2 neutrons in tritium. So let's do the same thing if we have lithium 7. So that 7 is telling you our mass. What is the atomic number for lithium? 3. So lithium 7 has 7 minus 3, 4 neutrons in it. Okay? So if we do the same thing for oxygen 18, what is our mass number? 18 minus...
Stability is radioactive?
The stability determines if it's radioactive. If it's unstable, you said the number is 8. So atomic number. So we end up with 10 neutrons on oxygen 18. Okay, questions there? Okay, the bottom part of this, they've written this in molecular notation. So molecular is for molecules. What is a molecule? An atom is just one thing.
A molecule is like the thing that it holds.
No, so a molecule, so you could have one atom of hydrogen.
Like the thing with the super something?
Kind of. If you have 2 hydrogen atoms, then they make a molecule. It's more than one atom of the element. So that's what molecular notation is telling you. They're going to give you the symbol for whatever element we're working with. So H is for hydrogen. And then the molecular part is this 2. The 2 is telling you there are 2 atoms. And then we have another element. O stands for oxygen. If there's no number there, what does that mean? Just one. So they're not going to fill in ones. If there's nothing there, then it's an invisible 1. Okay? So over on this top box, it says how many atoms of each element are there in CH4. So they broke this down. C stands for carbon. If it's just C by itself, there's only 1. H4, H is for hydrogen, and the 4 means there's 4 of them. So altogether, we have 5 total atoms. So if we do this for CO2, C stands for carbon. How many carbon atoms do we have? In CO2, how many carbon atoms do we have? Just 1. So we're looking at that there. O stands for oxygen. There's 2 of those. What was your question? They already did. And then, so 1 and 2 give us 3 total atoms in this molecule. Same thing for NaOH. What does Na stand for? Sodium. How many sodiums do we have? Just 1. O stands for oxygen. And NaOH, how many oxygens do we have? Again, no number there, it's just 1. And H, hydrogen, also just 1. altogether, again, 3 atoms in that element. I mean, that's not an element. Molecule. Questions about this first page? On the back, protons have what kind of charge?
Positive.
They're positively charged. Electrons are negative, they're opposites. You've heard opposites attract. Like a magnet, these pull together, but the like charges also repel each other. So opposites want to come together, the same things push each other apart. So even though like this seems pretty basic, but a lot of chemistry is based on this. If protons repel each other, how can the nucleus that has multiple protons stay together? So that's a big thing in chemistry.
How can a nucleus stay together?
Yeah. So we haven't talked about this yet. This is called strong nuclear, make sure I spell these right, nuclear force. Oops. Do you remember what the little pieces inside of a proton are called?
Atom.
No, the atom is the whole thing.
Molecule.
The little parts are called quarks. So these little pieces, the quarks inside protons and neutrons.
Is it with a S or a Z?
S. What? So the quarks inside these protons and neutrons create this strong nuclear force. So even though they want to repel, this strong nuclear force keeps them together enough that they can stay inside the nucleus.
I'm sorry. Mr. Stoop literally told me that I'm...
The last thing on this page is about electron orbits, and we're going to talk about this a lot more in detail this week. But because electrons don't like each other, they also repel like a magnet. They don't stay in the same spot. They fill up orbits. And each orbit can hold a certain number of electrons until it's full. If there's too many...
There's only 2 that you can put?
Yes. Each orbit has a different number that it can hold. So even though...
So the first one can only hold 2.
Right.
The second one can only hold 8.
Yeah. So we're gonna talk about these orbits a lot more this week. But this is the basics. Even though these are attracted to the protons in the nucleus, the having more electrons in there, like repelling each other, is what makes these electrons move around and orbit the atom. So here's a picture.
If it was just, like, if it was just positive, it wouldn't move. Or if it was just neutral, it would just move, it wouldn't move.
Because these are...
Orbit.
Because the electrons repel each other, but are still attracted to the nucleus. Like they want to be closer to protons, but they don't like each other. So they're just moving all over the place. So that's just some basic. We're not going to get into that very much today. We will talk about it a whole lot on Wednesday. Okay. Okay, we'll talk about these guys on the very bottom. We haven't had any readings. We talked about Dalton, I think, a teeny tiny bit. Dalton is the guy who made up atomic theory.
So A?
No, atomic theory. The atomic theory was that an atom has a nucleus. No, it's not here. And that they,
Bottom?
yeah, the nucleus, and that they like make the sphere around it.
Oh.
So Dalton is F. The second guy, Bohr, is the one who decided that these electrons have to go in levels.
D?
Yes.
Democritus.
Democritus is how I would say that, but sure, yes, same thing. He was very old. What kind of name does that sound like?
Democracy.
Which comes from what language?
Oh.
He's the Greek.
Greek?
He's the Greek guy.
It comes from Greek.
Yes. So he realized
So he's
that the world is made up of teeny tiny things and named the atom.
okay.
This is a typo. Democritus is the one who called these atoms. Rutherford is this gold guy. He did this gold foil experiment that proved atoms had a nucleus a long time ago. It was pretty significant there. Yes. So Rutherford is A. And then they try to trick you. That name kind of sounds familiar.
It's he's a lead singer from The Neighborhood.
Oh, maybe.
You know Sweater Weather.
Yeah. All right, so Rutherford was the guy in the 1800s who found the electron and other smaller particles. So just in case these show up, they're not going to be like test questions or anything, but so you know who those guys are. This the scientist that said atoms can be changed chemically.
Oh my lord. I'm gonna.
This is a trick. Atoms cannot be changed chemically. What happens if you change, like, the number of protons in an atom?
What'd you say?
What happens if you change the number of protons in an atom?
It's gonna
be something else.
Yeah.
So atoms cannot be changed. They're just rearranged. You should keep it for 45 more minutes. I can't spell. Are there two R's in rearrange? R-A-N-G. Okay, so the next page is an atom simulation. So on your device, this says go to www.tinyurl.com/ICP atom. And it should bring up this PhET simulator. So go ahead and open that. It says at the very top, click on the atom picture to start. Don't pick these two, start here. And then the website is www.tinyurl.com/atom. Nope, I'm sorry, ICP atom. www, this one. So if you're watching the video, go to this website and then unpause when you're done. So it says click on the atom, and then you're just going to drag. We've got protons, neutrons, and electrons. Start by opening the net charge. Okay, start by opening net charge and mass number, so you want to be able to see both of those. And then it tells you what to do. You're going to drag some protons on there. Where do they go? Drag neutrons. Where do they go? Electrons. And what happens to the number, changing the number of particles does what to the element? So it doesn't have to be a certain number. Do however many you like. But drag some of each see what happens. You can do all three, but it does ask about all three. If you do more, what happens? So go ahead and do that for yourself. So 1 through 9 are for this part. Actually, once you get to 10, it asks about ions and positive charges and all that. So this is telling you the net charge. So for when it says positive ion, this just needs to be a plus something. And your electrons, number of electrons changes that charge. So you can drag those around to change that net charge. They want you to do 1 positive, 1 negative, and 1 neutral. If you're watching the video, pause and do that section. Okay. On the back page, it asks you to play the game, so go ahead and click down here. It's got the game. And it asks you to do each one. So game 1 is this. See you tomorrow. And then once you're done with that, go back. Start over. Click start over, and then this is game 2. So do that one, and then start over for game 3. And then the same thing for game 4. And then there's a couple questions at the very, very end. And then go ahead and turn that page in for your assignment today.